Good morning, physicists. Today we are going to be working on a problem set that has to do with conservation of momentum. So I just wanted to do this quick introduction video to remind you that the conservation of momentum is the total momentum in a system remaining the same if no external forces act on the system. So that means, similar to conservation of energy, conservation of mass, it doesn't change. So it's just transformed or transferred in this case. So there are two types of collisions we're going to look at in these problems. There are elastic and inelastic collisions. An elastic collision is when two objects are going to collide and bounce apart from each other, and there's no energy loss. So the momentum may be transferred, and it's going to cause a change in the velocity of the two objects. An inelastic collision is one where the objects collide and some energy is transformed into heat. But what I added here is that they do not bounce apart. Rather, they connect together. So it would be like, for example, if two train cars, one ran into the back of another one and the clips locked together and then the two cars moved together. Or if a person was running down a field and tackled someone else, and when they tackled them, instead of just running into them and bouncing apart and colliding, they grabbed them and tackled them and pushed them as one unit afterwards. Okay, so there's two equations we're going to take a look at. Elastic collisions. Okay, so we want to remember that momentum, P, is mass times velocity. So if in a collision, the P or momentum before must equal the P after. So we have this equation. Here's momentum, mv. So mv1 initial plus m2 v2 initial. So that's before the collision. You have object 1, object 2. It has a mass and a velocity. I stands for its initial velocity. Okay, must equal the mass times velocity of the first object final plus the mass times the velocity final of the second object after the collision. Before the collision, after the collision. So we simply set these two things equal to each other and we solve for whatever it is we're missing. So we may have to manipulate this equation, and I will show you an example of one. Okay, the next piece is the inelastic collision. And that, again, the momentum before must equal after. However, in this case, before you have the two objects, momentum, mass, times velocity of the first object with its initial velocity, plus mass, velocity, initial of the second object. Okay, that's why we have 1 and 2. Here's before the collision, but notice after the collision, these two objects have combined. They did not bounce apart, they attach together. So we add their masses times the final velocity of this whole unit. Okay, and that's what makes these different. So let's make sure we have that in our notes, and I'm going to go over 3 sample problems with you right now.